So we're finally at part 4 of the video series, and this video is going to be about what we've been doing in the trunk of the E55. So I made this custom pushrod suspension for it, which seemed to be the ideal solution for fixing the balance of the car. Before it had a bit of understeer, so we needed to stiffen the rear to fix that understeer. And it was also important for getting the car back on the road, because if you remember from part 3, the airmatic stopped working after we removed the front struts, and the rear sank all the way to the ground. And the rear suspension that came with the coilover kit was not even compatible with this model. So yeah, this video is going to be about how I made the pushrod suspension and what are some of the benefits of it. So to start off, I took out all the trunk lining and everything, basically stripped out the trunk so I could make measurements on where to place the pushrod suspension, because the trunk was the only space where this could have been fitted, because there's not that much room underneath the car. So after I took all the measurements from my trunk, I just made a rough sketch of what I want my pushrod suspension to look like. And I did a few calculations on just to make sure what the spring rate is going to be after all of this is done. Because obviously the reason of going with the pushrod suspension is because I need a stiffer spring rate at the back. And I also, I made some rough estimates of what I need the sizes to be. But really now the next step is to go in 3D software and make a 3D model of all this. And that will really show me if everything will work together or not, and that really helps you visualize how everything is going to go together. Alright, so after I had done all my measurements in the trunk, I used those to make this model for the pushrod suspension. I designed it in 3ds Max, and it's really pretty simple designing something in this software. So I'll just explain the design a little bit. So all of this part over here, this is what will go in the trunk of the car. These two parts are where this main frame is going to bolt to the frame of the car. And these two red parts are the rockers. These are the parts that are going to basically pivot around these two ball joints. And they're going to compress the spring, the anti-roll bar. This over here is the anti-roll bar. And the shocks at the back, which I didn't make in too much detail, but that's where they will go. These are the push rods. They connect to this end of the rocker. There's a ball joint here, and there will be a ball joint over here. And this lower ball joint will connect at the lower control arm of the car suspension. And this end will go on the push rod, go on the rocker. And yeah, when the lower control arm moves up and down, it will move the rocker, and the rocker will move the spring. And the big difference between this and a conventional suspension is the leverage difference. So you can set the spring, you can basically move, so you can basically move the spring up or down along this rocker, and depending on where you position the spring, you can get a different spring rate from the suspension setup. Same with the anti-roll bar. There will be different points where you can bolt the anti-roll bar, and that will change the stiffness of your anti-roll bar. And the dampers are adjustable anyway, so I don't need to make this adjustable. And the ride height is also adjustable using by changing the length of the push rod. So yeah, this suspension just gives you a lot of adjustability. It's a great way to get a really stiff suspension setup. Okay, so after I was done designing the suspension, I made a list of all the different sizes of tubes I needed to make the suspension. And here's the list. I was just checking if I've gotten everything. And here's what all the tubes look like, cut to size. So after getting all these tubes, the next step is now to drill the holes, because even though these are cut to size, I will still need to drill the holes, and For some of the tubes that require being cut at an angle, I will have to cut those myself. And after they're cut and drilled properly, the next step would obviously be welding it all together. And then after welding, bolting it all in the car. Okay, so now I've welded the lower part of the frame together, and I welded these two nuts over here where the rocker arm will attach. And right now we're just welding the rocker arm. This thing is gonna sit. The ball joints are gonna bolt right in there. They're not aligned right now, that's why they're not going in. But yeah, this is the right size they will go in. I'm just following the measurements from the design and welding everything according to that. And once all the welding is complete, hopefully everything will be able to bolt together. Okay, so now for cutting the angle tubes, what I did was I marked the angle using a white marker, and I tried to match the angle so the chop saw would cut at over the white line exactly. You could also do it in degrees and adjust your chop saw according to the angle, but since these saws are not that accurate anyways, I'm just using this method. So after a lot of hard work, the rocker arms are finally complete. Now the next step is to paint it, because right now if I leave it like this metal is gonna get rusted pretty quickly. I'm thinking of painting it red just because in the design it was red. I got some help from a friend to drill the holes in the trunk where the frame would mount.
Let's see if this fits now.
Break the light.
I hate this so much.
Seems like you like being in there.
Oh, fuck, I still gotta go more.
Alright, so now I've put one of the rockers in place, and I've held the coil spring and the shock, and I was just measuring out where this other mounting point where the shock will go. I'll use it making this flat steel sheet, but I have to drill a hole in here, so and that's where it will go in between these two rubbers, and that's where the other part will mount. So yeah, once that's done, the next step is going to be to adjust the setting on this. So I can adjust where the suspension bottoms out. That bottom out is when the wheel goes all the way up, and just before it causes trouble, like just before it hits the fender well or just before the car hits the floor, this shock is supposed to bottom out and stop the suspension from going any lower. So now I'm getting pretty close to the point where I'm ready to just pick this up and bolt it in the car. I have the rocker mounted for one side, I have the shock absorber and the coil spring mounted. And right now I'm using these wire ties to hold the rocker in place. And that's because if I let it go, this shock absorber is going to open up all the way and push the rocker down all the way, and that's going to make this coil spring fall out. So I need to hold it in place until it's mounted in the car. But there was a bit of a problem with the other side, which is why the rocker is not mounted on. And that's because when I was designing the suspension, I took all the measurements from one side, so I made it according to that wheel well. Now the problem turned out to be that this side of the wheel well is not exactly the same as that side. There are actually fuel filler lines going from there, the line that goes from the fuel filler to the fuel tank, and that takes up quite a bit of space. So basically the problem is this wheel well does not have enough space as that wheel well, so if I was to mount the rocker arm on right now, it will hit the wheel well. So the solution is either I can modify the wheel well, cut it, which is going to be pretty difficult because it's 3 layers of metal, or the second solution is to modify my rocker arm, make that smaller so it can fit over there. Both of those are going to be difficult, but I'll just have to see which one I go with. Alright, now I finally put the frame and one side of the rocker in place, and now I'm lining the frame up with the holes over there so I can insert the bolts. And if I had another person right now, it would have been really easy, but I don't, so I'm using this threaded rod over here with this. I'm putting different things here just to get the angle right so I can line up the holes and put the bolts in. Alright, now I managed to get the bolts in. So now the whole thing is held in place by itself, as it should be held in. And the positive is that this rocker lines up pretty nicely with where it should be. But the negative thing is that this one doesn't. I've put this one in place just to see how much it was off by, and yeah, it doesn't go all the way down. It hits that part of the wheel well over there. That's how it is. It doesn't work, and I'll have to make some changes to make that fit. So after a bit of thinking, I've come up with a solution on how to make this side work, and the solution is to modify the rocker, but also to modify the fender well just a bit. I've already cut one of these sides off, the bottom things that goes on the other side. That was the place where the push rod was supposed to mount. But the problem is that it still doesn't go down all the way. It goes here and it still stops. And now to make it go down all the way, I'm thinking I'll just cut a bit of this wheel well out from here so this thing goes all the way down. I've already checked at the back there is enough space for the fuel filler lines that it will still not hit the rocker arm or whatever goes over there. So yeah, that's the next thing to do, cut this. The way I'm using to mark it is I don't feel like doing too much work. Just bash this a few times into the wheel well. That leaves a mark over there, and that's where I know where it's sitting. And I'll just cut that part out just a bit. Now, as if this day wasn't bad enough, another problem. While I was cutting the fender well, I guess the wheel well defeated the angle grinder and doesn't work anymore. That's the sound of broken gears. Just bought another angle grinder, and hopefully I will be able to complete the job with this. I'll obviously first we'll throw the instruction manual in the garbage. After cutting a hole in the fender well, moving the fuel filler pipe down back by a few millimeters, the worst part is still touches. It doesn't go down all the way. But I think now it is scraping so minor that I will be able to file just a bit more of the wheel well out, and then hopefully this will work. It's close enough that it should work. Okay, so now I just put the push rod in, and I'm gonna mark the push rod and cut the excess off. So the push rod is the right length, and after that bolt the push rods in and hope that it actually does sit at the right height. Alright, so now I've completed my push rods, and what I did after marking it was I just put both the tubes into the angle grinder and I cut them to size. After that I just welded this nut on the end. Let me focus the camera. There, after that I just welded this nut at the end, and after that I just painted the push rod. That's just so it doesn't rust. But so yeah, these two tubes, these are basically what's gonna hold the entire weight of the car. One ball joint is gonna attach to the lower arm. The other one is gonna go all the way up to the rocker over there. And yeah, that's basically what's holding the car up. So after a really long night of hard work, the pushrod suspension is finally complete, but it still needs adjustment. I haven't put the car down on its wheels yet. Yeah, I've been working on this all night, and now it's 10 a.m. in the morning again. Yeah, the push rods are in place. I just need to put the tire on for this side. The tire for the other side is on. But yeah, I just want to put the tire on for now and lower the car and see if everything holds on and if everything's okay. I just lowered the car for the first time on the pushrod suspension. This car has been standing on jack stands. I think it's been a month now almost. So yeah, I'm pretty happy that it's on the ground, and it's all the weight is right now on the pushrod suspension. That's the other side. And yeah, the calculations have worked pretty much perfectly. Even with zero spring preload, I put the car down and it's exactly at the point where the ride height width was intended to be according to the design. Of course, the ride height is adjustable by adjusting the spring preload. But the only flaw I can see right now is that if you notice the spring, it's bending a little bit downwards. That's because this part of my rocker is completely flat, whereas it's meant to be the shape of the spring, so the spring sits flat on it. But yeah, that's not even a really big issue. So after finishing the rear pushrod suspension, my first test drive unfortunately happened to be my drive to work, which was pretty scary, driving to work in a suspension you just completed a few minutes ago. But it all worked out fine. There was no problems or anything. And on the way back from work, I took a few sharp turns to see what the balance of the car was like. And the suspension just made a tremendous difference. Now it actually feels much more like a mid-engined race car rather than a front-engined family sedan. So it was pretty surprising. It made a huge difference. Now actually the balance is a little towards oversteer rather than understeer, which is not necessarily a good thing, because what I intended was that I still should have had a little bit of understeer left, so I could use the rear anti-roll bar to fix that and fine-tune the balance to exactly where I wanted it to be. But since it's already gone towards oversteer, what I need to do is I need to dial the rear suspension back a little, make it softer, so then when I put the anti-roll bar I can do the final adjustment using that. And the other thing I noticed is that now a locking differential has become even more critical than before. First, this car comes with an open differential, which is not good for the track because on corner exits you're spinning the inside rear tire, which means that you're losing a lot of power. You can't put all the power down on corner exits, and you lose track time because of that. But now it's become even more critical with the rear suspension to have a locking differential, because now more of the weight is shifted to the outside rear tire because of the stiffer suspension. And that means the inside tire is even more unloaded, and it spins even easier, and there's less acceleration on corner exits. So yeah, in part what's the next? In part 5, I'm gonna have to soften the rear suspension, maybe put in an anti-roll bar, and do something about the differential. But we're getting pretty close to our next track day. Part 6 is for sure going to be the next track day, and we really need to get there because we're already behind schedule for what we planned in order to finish the car by September for the CSCS. But the good thing is the changes are looking really positive so far, and all these changes do go hand in hand. Like the rear suspension has to go together with the differential. The slick tires do have to go with the suspension, because if you're putting tires on that are going to change the balance of the car, you need to change the suspension too to correct that balance. So yeah, I believe it's an overall package, and it all has to go together to see a positive change in track time. But the good thing is it is looking positive so far. And also for the next track day, I've ordered a few new cameras, and I'm planning to put one camera on the pushrod suspension and a few cameras on other places around the car, so I'll get some really good footage for the next track day. So hopefully that should be really fun. But it's just that I have to do a few small changes on the car before I get to the next track day, just to make sure that everything works together and it's a good overall package. So yeah, that's all to come in part 5 and part 6, I guess. For now, this is what the car is. It's looking good so far, but hopefully it's gonna look even better after the next few changes are made.